Welcome back. I'm sure you would have enjoyed that break. You stretched a bit and did a bit of an exercise and whatever that influenced you to get here. So thank you for coming back. Let's move on to seeing what's about on day one. The materials or equipment for you to learn and practice yourself are the following. So you need to have a STM32F411 RE nuclear board. Um, one that would look like this, and a logic analyzer, ESP8266 a Wi-Fi module, DHTL11 sensor, ADXL345 another sensor circuit, and some LEDs and 330 ohms resistors and a relay, and the Bluetooth module HC05. You can accumulate and acquire all of that by contacting Pantex Solutions. They are a very big company and they would be able to help you. They are a friendly team. They would be able to help you to procure all of this. So please do contact Pantex Solutions for that. Okay, self-investment. What is that? Self-investment is the best investment that you can do by investing on you. Yes, on you. You got that right. Yes, investing on you. We all are, including me, we are happy to invest a lot of time to our traveling, our entertainment, eating out in fancy restaurants or roadside shops, snacks, whatever you name it. But if you could please limit the above and invest more on you, that's going to shape up your future. Yes, believe you me, I was like that years ago, and through all my mentors that where I am now, they really helped. So I was investing on myself to educate myself, to improve my skills. So over the years, I'm still doing on this day, I'm trying to learn a bit every day. So a self investment is a good thing. So if you haven't already started, please take my word, please self invest on you, and that will really help you to be a better professional for the future. Just to add to that, you can watch hundreds of videos and observe a lot of things done by others. You can watch and observe and put it in memory. For example, in driving or riding a scooter or riding a horse, for instance. You can watch plenty of that and read a lot about it, but unless you start to practice yourself, you won't be able to achieve the success. For example, attaining your driving license. I'm sure driving license is one of the important license to have, because when you get into that industry, there will be occasions where you need to cover sites. So they will give you a company vehicle you need to drive. I'm not scaring you, but through my experience, I felt that, so I'm just passing that to you. So a driver's license comes in really handy. Unless you start to practice, you get that fear out of your mind, and then you will be more comfortable once you know because you practiced. So likewise, you have to practice embedded system design on the STM32F4 that I'm going to teach you. So with lots of practice, you'll be more familiar and come up with your own unique products and projects. So please start that habit and practice yourself. Reach out to Pantex Solutions to acquire all those materials that I listed, and you would be able to start to practice. So please follow that. So on your marks, settle yourself. Here we go. Let's go. Let's get in. Day one of the beginner session. This is about the introduction to embedded systems. It begins like this now. What is an embedded system? Most of you are fresher just out of the engineering course degree, or even if you have some experience, and I'm sure all my fellow engineers, even who are watching this, will agree with me with this definition. An embedded system is a combination of both hardware and a software with some associated mechanical parts in some cases to perform a specific task. That is called an embedded system. I repeat again, an embedded system is a combination of both hardware and software with some associated mechanical parts in some cases to perform a specific task. And that's what an embedded system is. You can compare the embedded system to a desktop, which you are seeing now, a laptop or your mobile. So those are all desktop operating systems, whereas embedded system has its own operating systems. So that is the difference I'm trying to point out here. So they are totally different. The embedded system examples I given you a few. There are printer because it's allocated to do one task, printing. So that is an embedded system. A washing machine, it allocated to perform a task to wash your clothes. So there is a controller. You set your timing and then press start and it does the washing for you. Also microwave. So you put your plate of food in the microwave and set the time and then set it to reheat or even to cook. So that's performing that task. So overall, that's what it is, an embedded system to perform a specific task with some mechanical part movements that has association with both hardware and software. So this is an embedded system. Now let's move into classification of embedded systems. There are different classifications out there. This is the three main classifications that I would like to point out to you. The first is of the rank is the real-time embedded system. You will hear and learn a lot about real-time all the time, so that is the must, and it is one of the real hard module, if you like, on its own. What is a real-time embedded system? A system that completes the task within a specific time. So if it runs on a time-specific related project, then that's called a real-time embedded system, which your project is running according to a schedule and has to finish on that time. So that is a real-time embedded system. The real-time embedded system can be classified again into hard real-time and soft real-time. The hard real-time is the major one. For example, if your project misses a critical deadline, it will create a catastrophe or even a major problem in case of death, etc. For example, spacecrafts I've given you, but right at this presence of mine, a new thing comes in my mind. I'm sorry to bring this up in this one, but it could be a failure of the train collision accident that happened, and please God, sorry, we lost a lot of loved souls on that critical day. So that could be part of a critical deadline missing. Someone forgot to do something, so they end up having a collision. So like that, for example, in spacecrafts, if they miss a deadline, then they may not be able to land on the space, and they may have to come out of space or maybe even drop out of it and may cause to death. So that's what it really means. So if it misses a deadline, it's going to create a havoc and create a lot of problems around it. Whereas soft real time doesn't create a big major issue, but it degrades the quality of whatever your system is built to do. For instance, audio and video software. So if you're listening to a podcast, if there is some background noise, it doesn't affect anything on the output side of it, but you get the disturbance, noise disturbance. And video, for example, you're playing a game and something interrupts the video, start to startle, and that degrades your mood and also your interest. So that's a software real time. And there is the next one is the network embedded system. I personally worked in those two industries, ATMs and point of sale. So how the embedded network system is connected through the networks. For instance, tapping your ATM card on an ATM machine, how it connects to your bank account and how it processes all that behind the scenes and bring the money to you. So all that it's classified in the network system. And also point of sales. You're going to a mall, and if you're buying something, at the point of sale, you're going to tap your card for the payment, and that's the point of sale system, and that's a network embedded system. And the mobile embedded system is the next one. Mobile embedded system is a standalone system where it operates by mainly with the battery power. For example, a pacemaker, a substitute for your heart in the surgeon. And the surgeons use to help people alive, they use a pacemaker, and that operates by battery power. And that's classified as a mobile embedded system because it's a standalone system. Now let's move to learn about what are all the processors and controllers that we using or everyone using out there in the embedded systems. Microprocessors and microcontrollers. The examples are 8085 and 8051. Then down next one is the DSP, digital signal processing, and DSC is a digital signal controller. A very good example is TMS 320C 6000 and a TSM 320C 2000. And next one down is the CPLD and FPGA. CPLD stands for complex programmable logic devices, and that's obsolete now. So most of the companies now do FPGA. That's the trend going on. FPGA stands for Field Programmable Gate Array, and an example for CPLD is Xilinx Cool Runner, and an example for an FPGA is Zinc. And then there is the next processor is ASIC. ASIC stands for Application Specific Integrated Circuit. It's meant to do only for that application. So an example is an Intel Movi disk stick. And then down next one is the SoC, System on a Chip. What you can do everything on a single chip. An example to that is ESP32S3 and the OMAP series from Texas Instruments. So that's a system on chip. And the latest one or the current one that not many of us would be aware is the TPU. It's a tensor processing unit developed by Google, and they come up with their own product called Google Coral, and that does help in their systems and linking with their AI with the cloud. So these are all the different processors and controllers in the embedded systems. Next is what are all the programming languages that you could choose for designing your embedded system. When I started learning about embedded systems or even know about the concepts about embedded system, assembly languages was the key role for embedded system. Not at all, but that's how I started learning. So assembly languages out there, and the current hard programming languages out used is embedded C in a lot of industries. And there is also a mixed C and an assembly language programming. And Python, yes, you can write Python scripts that will help you in the embedded system coding, and that's the real trend, and they link with AI intelligence. So Python is there. And HDL, there is another stream called HDL that's related to VLSI. So if you want to learn Verilog, VHDL sort of languages, in HDL, hardware description language it's called. And then there is a graphical or a visual languages that you don't need any code. Simply you drag an image and put it in the code, and it does everything for you, and it saves you writing down. For example, MATLAB. If you use MATLAB, you can do the graphical and visual. And also for DSP applications, like if you want to sense an image or sense a video clip, you can use those languages and you can do that. So these are all some of the programming languages that they're mainly used in the industry that I'm putting it out there for your knowledge. And as you all may be aware, because if you are from the electronics design or electronics engineering background, every microcontroller have to interface with a peripheral to do your activities, whatever you're writing code for. So these are all on the left side. These are all the peripherals that I'm going to cover for the next 30 days. And the right side, these are all the other available peripherals that you could develop your skills from this, and you could write codes to help on those. So I'm going to cover you the peripherals to interface with GPIOs, the UART, I2C, the SPI communication protocol, ADC, analog digital converter, interrupt, pulse width modulation, PWM, and timers. So these are all the generic, the must-haves for your future, for you to start and the one on the right side is more advanced, more in depth. So once you know and master everything on the left, I'm pretty sure you can do everything by yourself on the right. So the principle stays everything the same. So you can carry over that principle and your logic that you use to learn from this, move on to the right side, and you would be able to interface these peripherals to your microcontroller, which I would be able to assist you in the Facebook groups. Like if you want to get more information, I'll provide it to you there. Now let's see what are all the companies they are dominant in manufacturing the processor. If you take general CPU, the general CPU, Intel and Samsung and AMD, that if you see your laptop, your PC, you will see a logo or a sticker sticking around in the corner showing Intel or Samsung or AMD. So they are the general CPUs for the desktops. And there is general purpose units which are highly targeted for your graphics card about the see-through feel, like look feel. And Nvidia is the major manufacturer for the graphics. So Nvidia nobody can beat. I'm sure there could be some, but Nvidia graphics card is better. And as I told you earlier, the TPU, the tensor processing unit, Google developed that, and they come up with their own product, Coral and Hilo are the TPUs. And this is where our course is going to highlight the embedded CPU. There are plenty of manufacturers for embedded microcontrollers in the CPUs. These are all the major players in the industry: Texas Instruments, Analog Devices, Microchip, ST Microelectronics. Yes, this course is, we're going to use the STM32F411, so that's manufactured by ST Microelectronics. There is Cypress, there is Intel, that's AMD. So these are all the companies who dominate in manufacturing various different CPUs. Now let's briefly see what are all the companies they design the processor core. Yes, to design a system, you need a processor core where it's the heart of that design of that system. So everything will come with the processor core. And to give you some examples, the 8051, Intel is the process core manufacturing company who produces the 8051. ARM produces its own core on LPC 2148, STM32, and these are all manufactured. ARM is not a manufacturing company, for information. They only design processor core. So the companies like STM32, they buy the processor core from ARM and they use it in their projects and in their applications. And another design processing core company is PIC. PIC is another microcontroller which has the processor core, comes from Microchip, which you will learn eventually in the other projects. And Tensilica, another processor core designed by Cadence Design Systems, ESP32. Okay, I think I'll give you another briefer, so please go out there and relax, and I'll see you back in 5 minutes. See you then. Bye for now.